A few considerations that are worth keeping in mind when thinking about the prevalence. And these considerations, I would have to say, are applicable to other parts of the epidemiological toolbox as well, but we'll discuss them here and then you can carry them along. Stability of criteria. Definitions might be revised. For instance, risky drinking might mean something today. It was different perhaps 50 years ago, and so on. There might be new protocols and questionnaires for screening. One could think about there's a range of different questionnaires for measuring quality of life, for instance. And depending on which one you use and revisions to those questionnaires, the prevalence will change. Technological advancements and new biomarkers. We might get better at identifying cases. Local and cultural differences. Again, risky drinking is defined differently in different countries. Political leadership and incentives that might engage new strategies for measuring prevalence, and that changes the prevalence rate. And ICD definitions and other sort of protocols and decision trees for deciding if somebody is a case or not. So we have everything from unstable criteria based on assumptions by practitioners or responders to stable criteria based on conventions, but even these might change over time. So what is the actual prevalence when definitions and criteria change? So all of these things that I mentioned changes the prevalence that we measure without the population that we're studying changing at all. The population have stayed the same, but we're changing how we measure and what we define as a case, and therefore the prevalence changes. This makes it tricky sometimes to actually compare between countries, compare over time, because we have to bear in mind, well, how were they defining that type of factor when they did that study? What tools did they have? And so on. Here's an example of alcohol screening. So there are different ways that you could screen an individual to be a person that could be helped by getting some more treatment or by giving some behavioral intervention or something like that. One of them is CAGE, where you ask 4 questions. Have you ever felt the need to cut down your drinking? Have you ever felt annoyed by someone criticizing your drinking? Have you ever felt bad or guilty about your drinking? Have you ever had an eye-opener, a drink the first thing in the morning to steady your nerves? Responding yes to one of the more questions denotes a need for further assessment. Okay. Audit C is another tool which is commonly used. How often do you have a drink containing alcohol? And then there are a set of options here. How many standard drinks containing alcohol do you have on a typical day when you're drinking? A set of options here. How often do you have 6 more drinks on one occasion? A set of options here. Okay. And there's a scoring here, which gives you a score, and this score has different cutoffs if you're female or if you're male. Okay, so then if we have different criteria for men and women in Audit C, but not in CAGE, and CAGE is really based on perception and Audit C is based on consumption, then using these two to define somebody who needs more help, then the prevalence of individuals who could use more help with their alcohol consumption looks very different depending on which sort of tool you're using and questionnaire you're using. Because these are very, very different. But they're trying to do the same thing. They're trying to screen for people with alcohol problems. So let's look at a concrete example of this. Risky drinking in Sweden. CAN, the Centre for Alcohol and Narcotics, does a measurement of risky drinking in Sweden. So does the Public Health Agency of Sweden. CAN defines risky drinking as more than 9 or 14 drinks per week, depending on your female and male, or if you at least once a month have an episode of heavy drinking, which means that you drink more than 3 or 4 units on the same occasion. According to these criteria, risky drinking in Sweden is prevalent in 22% of females and 38% of males. Now, the Public Health Agency of Sweden, they use Audit C, this one, the questionnaire I showed you earlier. And they have measured that risky drinking is prevalent among 13% of females and 20% of males. So what's the actual prevalence when definitions and criteria are different? Which one should we trust? And I'd say these are quite big differences in risky drinking. And so it's sometimes hard to communicate then when there are different measurements of risky drinking. Okay. Missing or selective data. We rarely, if ever, have the entire population of interest in our cohort, as we looked at in the demonstration. But we often and almost always want to infer something about the population. Those data points that are missing may bias our results. You see here, we've measured some individuals, so we know if they're a case or a non-case. But the rest, we don't know. We haven't observed them, so we have no idea. And we have to ask ourselves then, would the measured prevalence be the same if we included everyone? Are some individuals, defined by some characteristics, more or less likely to be part of our cohort? That is there a systematic sampling? Is the cohort sampled from the population which we want to infer something about? That's not always true, because sometimes you want to infer something about, let's say, all Swedish students, all Swedish university students, but you sample them from one university. So then you can't generalize to the rest of Sweden. And also, are you trying to generalize to the same definition of the population from which the cohort was sampled? Let's say that you decided that you wanted to do a survey among university students at Linköping University, and you do that, but you included only those who are program students. Can you then generalize to students who are only taking single courses? So can you generalize to all university students your findings? So missing and selective data is very tricky. And I recommend reading Selection Bias on the Catalog of Bias. And we will touch upon missing data in coming sessions here. And finally, the final consideration I'd like to raise here is how we define a case. So when we talk about cases, we make the assumption that people can be placed in either the affected or non-affected group, either your presence or absence. This is also very often a very useful assumption, but it can be also very misleading. So naturally, there's a difference between those who have been exposed to asbestos once every day versus those who have been exposed to asbestos once every month. There's a difference between those who smoke a cigarette a week versus those who smoke a pack a day. If we just bunch them together as smokers, we could do that, but is that what we mean by a smoker? Now, I would say it's not often the precise measurement of a phenomena that's important in epidemiology. In physics, it's very important, but in epidemiology, I would say it's rather that it's more important to have a measurement that can help us make people more healthy. It's not important to know if an individual smoked 37 or 45 cigarettes last week. It might just be valuable for us to know, did you smoke every day last week? Okay? So defining cases and defining what we mean with somebody that has been exposed to asbestos, or somebody that has been smoking, somebody that has been exposed to secondhand smoking, for instance. How do we define those things? Well, we should really aim to do it in a way that helps us make people more healthy and maybe not obsess too much about making precise measurements. A case or an affected individual may be defined in several ways when a dichotomy is not natural. We, for instance, have statistical cutoffs. Some people use this. They use two standard deviations away from the conditional mean. Sort of abnormal values are considered cases. Clinically relevant cutoffs. So risky drinkers are at higher risk of negative consequences. That's why we often look at risky drinkers. But in reality, all alcohol consumption might be dangerous. But maybe for the intervention that we're designing right now, we're interested in the risky drinkers, and that's why we make a cutoff. A prognostic values, it might be the case that values behind a specific threshold aren't very useful for us in making a prognosis for a patient, and therefore that's the cutoff that we use to define a case and another case. Or operational, like a rule of thumb which helps us to identify people at risk. For instance, BMI cutoffs. They're easy to remember, but that doesn't mean that people just below a certain cutoff is without risk. But it might be the case that we accept the fact that we use these cutoffs because they're easier to operationalize than ask people to remember an entire scale. I want to give a caveat here. The thing is, you lose information when you create cutoffs. Sometimes that's acceptable and sometimes it's not. Consult somebody. So for every study where you have to do this, you have to think really hard about if it's natural to split the sample or not split the sample, so to speak. Ideally, from a statistical or data analysis perspective, you want to keep something that is continuous. You don't want to make, I'd say, arbitrary categories. You'd like to try to avoid that. Sometimes you can't avoid it, but every study is going to be unique, and you have to think about what the consequences are of making those decisions.